Welcome to the new lecture on extractive metallurgy. So basically I have taken a lot of problems and I am going to discuss it in very details. I will give you all the concepts as well as their chemistry that is related with these problems. So basically I have tried to explain the various concepts of the extractive metallurgy with the help of these outstanding problems. Now let's see the first problem, that is the match type problems, that is the matching type, and we have list A1 and list 2, and we have to match with the correct code given. First is one Urkel method, and we know that one Urkel method is the method of purification of titanium. So if we have impure titanium and we just want to pure it, then you have to just heat it at 500 Kelvin in presence of iodine. Iodine forms a complex like TiI4 with the titanium, and this complex is thermally unstable. So when it is heated above 1700 Kelvin, that is the 1700 Kelvin, then it produces titanium that is in pure form, as well as iodine is produced. So one Urkel method is basically the purification of the titanium. So we can match A with the 2. Similarly, second is Solvay process, and Solvay ammonia process is method of purification of washing soda. So it will match with the 3. Cupellation is the method of purification of silver. So refining of silver, not purification. So we are just refining it further. So that is the 5th. C will match with the 5th. And poling, in which we use green pole of wood, is used for what? Purification of copper. So basically A is matching with 2, then B is matching with 3, C is matching with 5, D is matching with 4. 2, 3, 5, 4. So we can see C option is what? 2, 3, 5, 4. So correct option is what? C in this case. Now let's move to the new question. Match the list 1 with the list 2. Again it is a matching type problem, and we have to match it with the correct answers using the codes given here. So this is the list 1 and this is the list 2, and first is cyanide process. MacArthur Forest cyanide process, as we know, is used for the extraction of the gold and silver. So A will match with the what? D. Flotation process is used for the beneficiation or the concentration of the sulfide ore. Now for the flotation process we use pine oil as the frother, so B is related with the flotation process. Electrolytic reduction is used in the extraction of aluminum, okay, where it is extracted by the Hall-Héroult process. So 3 is matching with the C. And Jordan refining is used for the purification of the silicon and germanium. So this is matching with A. So in Jordan refining process, already I have discussed. There is a separate lecture for the Jordan refining where I have discussed this Jordan refining process in details, and this is used to get the ultra pure silicon and germanium. So for this the correct option is B, that is D, B, C, A. Okay, so B is the correct option in this case. Now let's move to the next question. The next question is the substance which is used as a flux in extraction of iron from hematite ore is, and that is very simple. The limestone is the flux that is used for the extraction of iron from hematite. As we know, as we use the limestone, that is CaCO3, is decomposed into CaO plus CO2. And again we know that CaO is basic flux. So CaO reacts with the acidic gangue present in the iron ore, that is SiO2, and slag, that is CaSiO3, is produced. So this is the slag in this case. So limestone is used as a flux in the extraction of iron. That's it. Now move to the next problem. Question is the composition of met is. So we know that the met is related with the extraction of copper from the chalcopyrite, and met mostly contains the Cu2s and Fes. So option A is correct for this case. The composition of met is Cu2s and Fes. So the option A is correct in this case. Now move to the next. Cyanide solution is used in the extraction of, okay, if you know the cyanide process, the cyanide is used in the extraction of silver as well as in gold. So option D is correct, that is called cyanide process, and this is used for the complex formation. Ag is there, Cn minus is there. In presence of oxygen, it forms a complex, that is Ag Cn whole twice minus. Okay, now we use zinc to separate out Ag out of this, and zinc will form complex with the cyanide. So basically cyanide solution is used in the extraction of gold and silver. Moving to the next question. In the extractive metallurgy of the iron, the highest temperature in the blast furnace is found in the, so in the blast furnace highest temperature is found in the lowermost part of the blast furnace where the combustion of coke takes place. The combustion of coke, complete combustion gives what? CO2 is the lowermost part of the blast furnace, and the temperature of the lowermost part of the blast furnace is very high. It is around 2170 Kelvin. So this temperature is very high, 2170 Kelvin at the lowermost part of the blast furnace where the combustion of coke takes place. Moving to the next. Aluminum is obtained in large quantity by. So today's aluminum, the commercial production of aluminum is done by the help of the Hall Herold process. Okay, and that is the electrolytic reduction of alumina that is dissolved in cryolite. So you can see the fourth option, that is the electrolytic reduction of alumina dissolved in cryolite, that is Na3Al(F)6, that is the cryolite, and that decreases the melting point of the aluminum mixture. Okay, decreases up to 1000 degrees centigrade. So this is the option D is correct in this case. Now next problem. Chemical reduction method is not used for. Okay, now let's see here in which of this chemical reduction method is not used. Now question is first is extraction of magnesium from anhydrous magnesium chlorides. Yes, if you want to just anhydrous magnesium chloride is here, and if you want to reduce the magnesium because it is in +2 oxidation state to magnesium, you need electrolytic reduction method. Okay, so if you have to take two electrodes, that is the one is the anode and cathode, where at the cathode this Mg2 plus will turn into what? Magnesium, by taking 2 electron from the solution, 2 electron, and it will form what? Mg. So that is done by the electrolytic reduction. So the extraction of magnesium from anhydrous magnesium chloride is not done by the chemical reduction like carbon reduction or whatever, because magnesium itself is a very good reducing agent. So magnesium being the strong reducing agent, it can't be get reduced by any chemical reduction method. So first option is correct, because only the electrolytic reduction or electrolysis can be used for the extraction of magnesium. Second is the extraction of copper from cuprite. Yes, carbon reduction is done here as well as the self reduction. The extraction of iron from hematite, again carbon reduction or Reduction by carbon monoxide is done in blast furnace. Extraction of zinc from zinc-site. Yes, again here calcination as well as carbon reduction from the ZNO takes place. So the option A is incorrect, and we know that magnesium from anhydrous magnesium chloride can't be reduced by chemical method. It will always be reduced by the help of what? Electrolytic reduction. And the reason is simple. Magnesium, being the alkaline earth metal, has very strong a strong reducing agent. Next, in the electrolytic reduction of fused mixture of Al2O3 and Na3LF6, the gas liberated at the graphite anode is. So basically, in the Hall-Herold process, aluminum in Al2O3 is in +3 oxidation state. So at the cathode, aluminum takes 3 electron and it forms aluminum metal, and at anode there is carbon, and that is the graphite, or that is the carbon, and oxygen oxide ion is in the melt. It reacts with that and it forms what? Oxygen gas, because it liberates oxygen, because oxide is oxidized at the anode, and here aluminum 3 plus is reduced at the cathode. This is the redox reaction that takes place in the extraction of aluminum by Hall-Herold process, and as this oxide is formed, as this oxygen is formed, this oxygen react with carbon to form carbon dioxide as well as carbon monoxide. So carbon monoxide and carbon dioxide both are formed. So basically, in this question, it is given that the gas liberated at the graphite anode is what? O2, and O2 that is liberated again react with carbon of the graphite to form CO and CO2. So I have already explained this Hall-Herold process in one of my lecture in very details. So if you have any query about the whole process, then go to that video lecture. Okay. Now next, which of the following statement is incorrect? Now let's see. Silver glance is mainly silver sulfide. Yes, this is absolutely correct, because silver sulfide is what? Ag2S, and that is called silver glance. Now this is correct. Copper pyrite mainly contains CuFeS2. Again, this is correct. Copper pyrite or chalcopyrite is CuFeS2. Zinc blends mainly contains ZnSO4. No, zinc blend is ZnS, not ZnSO4. So C is incorrect. And magnetite is the mixed oxide of Fu and Fe2O3. Again, this is correct. So only option C is incorrect. So the correct answer is what? C. Move to the question next question. In which of the following metallurgical process leaching is not involved? So as we know, leaching is a hydrometallurgical process. Now aluminum from Al2O3, yes, to get alumina from the bauxite, okay, we do the leaching. Let's see. Bauxite, that is Al2O3.2H2O, is first dissolved in NaOH, that is the base, in presence of aqueous NaOH is there, and we get what? NaAlO2. So that is the leaching process that is done in the Beer's process. We have to dissolve the alumina in strong base, that is the sodium hydroxide. So that is in the Beer's process, leaching is involved. Now Ag from Ag2S, again in Ag2S we use Cn minus, okay, and we get the complex AgCN2 minus. So again, leaching is done in case of argentite ore also. Now from magnesium from MgCl to anhydrous, here leaching is not done. No leaching is required in this case, so the correct option is what? C. Forming low grade copper ore and scraps. Yes, from low grade copper ores. Yes. This is also important. Then leaching is done in case of Beer's process, cyanide process, as well as for the production of copper from the low grade cuprite or Cu2 is there. We have leaching agent, leached agent as H2SO4 in this case, aqueous H2SO4, and we will get what? Copper sulfate and H2O. So in this case, what? The leaching agent is copper sulfate, sorry, H2SO4, and the product is copper sulfate. So again we can say that leaching is also used in case of what? Low grade copper ore. Okay, so again option will be what? Option will be C. In this case no leaching is required. Now move to the next question. Which of the following statement is incorrect? Beneficiation of ore involves the process which are used for the removal of unwanted impurities. Yes, this statement is absolutely correct. We want to remove the unwanted impurities, that's why we do the mineral beneficiation. Next is in metallurgy, flux is a substance which is used to convert infusible impurities to fusible impurities. Again, this is absolutely correct. Third is aluminum is extracted by electrolysis of alumina. Alumina is Al2O3, but electrolysis of alumina is not only done, it is done by mixing it with what? Cryolite. So this statement is incorrect because in this no cryolite is mentioned. In a smelting process, the metal is obtained in fused state. Yes, in a smelting, the molten metal is basically obtained. So the third option, option C, is incorrect. So our correct option is what? C in this case. This statement is incorrect. So answer is what? C. Now let's move to the next question. Leaching the silver and gold metal with cyanide is what? Is a oxidation reaction, is a complexation reaction, is a reduction reaction, is both A and B. Now if you see the main reaction of leaching, then we have to use cyanide minus in case of Ag with water as well as oxygen gas that is used for the oxidation. The complex that is formed is what? AgCN whole twice minus. So here Ag oxidation state is 0, in this case oxidation state is 1. So this is what? Oxidation reaction. Again this is a complex of what? Ag, so this is also a complexation reaction. So leaching basically is both oxidation as well as complexation reaction. So the correct option is what? Option D in this case, because it involves both. Now the next is leaching of low grade copper ore is carried by what? The leaching agent is what? Sulfuric acid. We have seen earlier, that is the sulfuric acid, and it was forming what? Copper sulfate. Now moving to the next. Which of the following reaction represent Goldsmith aluminothermite reaction? Okay, aluminothermite reaction in which we use alumina that acts as a reducing agent that reduces the metallic oxide, and metal is obtained that lie below the alumina in electrochemical series. So like thermite reaction is what? Fe3O4 plus aluminum, sorry, Fe2O3 plus aluminum. What we get? We get Al2O3 plus Fe. So in the similar way, Goldsmith aluminothermite processes, this one, aluminum is acting as what? Reducing agent. Aluminum has more affinity towards oxygen, so it can grab the oxygen out of this chromium oxide, and chromium and alumina will be formed. Also, if you see the electrochemical series, aluminum will lie above the chromium, so we can say that aluminum is better reducing agent than chromium, and it can easily reduce the chromium metal. Moving to the next question. It is the material that are added along with the calcined iron ore in the blast furnace in the extraction of iron from hematites. So what are the material that is used? All we know that what coke and limestone. These are the materials that we used in the production, okay, of the calcined ore in the blast furnace. That is the coke and limestone. So option B is correct in this case. Now one more question is there. Calcium is extracted by electrolysis of what? So the correct answer for this is fused mixture of calcium chloride and calcium fluoride. And we got calcium 2 plus in this fused mixture. We have to do electrolytic reduction or electrolysis, and we will get calcium at the cathode in this case. Next is, in which of the following pairs of the metal both are commercially extracted from respective ore by self reduction process? So as we know that self reduction process, copper, Hg, Pb, they undergo self reduction process. Now first we see that the first option is zinc and copper. No, zinc is done, reduction of zinc is done by carbon reduction. As we know, it gives you zinc and CO, so this is not correct. Copper, yes, copper is reduced by self reduction. Pb, yes, and copper, yes, so option B is correct. Sn, no, because Sn, the ore is SnO2, and we do carbon reduction to get first what? SnO plus CO, and again carbon reduction to get Sn. So zinc, that is correct. Aluminum, no, carbon reduction not done, electrolytic reduction is done. 4Ag, no, cyanide process is done. So the correct answer is what? Pb. As we know, in case of Pb, PbO is formed as well as PbS, that is the galena. They do the self reduction, we will get what? Pb and SO2. Similarly, for copper sulfate and copper sulfide and copper oxide is there, they go self reduction and they form what? Cu and SO2. In both of these self reduction, S minus 2, that is very important point. S minus 2, that is the sulfide ion, acts as a reducing agent. They go from minus 2 to plus 4 oxidation state. So itself it is getting oxidized. So we can say that sulfide ion acts as a reducing agent. Now, which of the following is obtained by zone refining methods? So we know that for the zone refining method is done for obtaining the ultra pure silicon and germanium. So highly pure ore, no. Highly pure aluminum, no. Ultra pure oxide, no. Ultra pure metal used as semiconductor, yes. You know that semiconductor, silicon, germanium, gallium, these are used for the semiconductor devices, and they are prepared from the zone refining process because we need them in very high purity. Now there is a simple comprehension. Now let's solve this. Read this following comprehension carefully and answer the question. Main ore of galena, lead is galena, and this is mined and separated from other minerals by the froth flotation. There are two methods of extraction of lead. First method involves the roasting of ore followed by the reduction with coke or carbon monoxide. Second method involves the partial roasting followed by self reduction. The partial roasting of the galena gives what? So if you do the partial roasting, that is the PBS, and oxygen is there. If you do the partial roasting, some of the PBS will convert to PBO and some PBS will left unconverted. So the mixture will contain what? PBO and PBS both. So correct option for this is what? Option C. So for this question, option C is correct. In self reduction, the species which brings about the reduction is So self reduction is what? PbO plus PbS giving Pb plus SO2. And I have told you just earlier I have told you that in this self reduction S minus 2, that is the sulfide ion, acts as a reducing agent. So the correct option is what? Option B is correct in this case. Now see the next question. Which of the following statement is incorrect about the extraction of lead from the galena? First is galena is a sulfide ore and therefore it is concentrated by froth flotation process. Yes, this is absolutely correct that PBS, the galena is a sulfide ore, and we know that for sulfide ore we do froth flotation process. Self reduction takes place in absence of air. Yes, because PbO and PbS is there, and this S minus 2 acts as a reducing agent. Complete roasting of galena gives PbO, which is then reduced by coke to metallic lead. Yes, if you do complete reaction, it will give you what? PbO plus SO2. And you can also do carbon reduction and you will get Pb plus Co. So carbon reduction as well as self reduction, both are possible for the PbO. FeSiO3 is obtained at the slag. This is not correct. This slag is obtained in the extraction of what? Copper. So this is not the slag that we will obtain here. Okay, that is the slag that is obtained in the case of extraction of copper from the chalcopyrite. Now again match the method of concentration of the ore in the column 1 with the 2. Leaching is used for what? Copper pyrite? No. Magnesite? No. Bauxite? Yes. Leaching agent is NaOH in this case. Calcination is done for what? Copper pyrite? No. Magnesite? Yes. Magnesite is MgCO3, so you have to do calcination for this, for the carbonate ore. You have to heat it, and after calcination it will give you what? MgO and CO2. Basically it will give you MgO and CO2. So for that Q is the answer. Fourth flotation is used for the sulfide ore, and we know that copper pyrite, that is CuFeS2 or chalcopyrite, is the sulfide ore, that is the CuFeS2. We can use the froth flotation process. Now magnetic separation. Okay, so magnetic separation is used for the magnetic ore, and we know that chromite, that is the S, chromite is magnetic in nature. Chromite ore is just FeO.Cr2O3. So this is magnetic in nature, and due to that magnetic property is separated from non-magnetic siliceous impurities by the magnetic separation method. So the correct option is what? RQPS, or option B is correct in this case. So option B is correct in this case. So now that is the end of this lecture. Thank you very much.